Hi, today we are going to talk about coordinates. Have you ever tried finding a location on Google Maps without GPS? It is quite hard because we need to describe it with latitude and longitude coordinates. If we consider the map as a flat plane and provide it with axes, then we can start plotting coordinates. There are two ways to define a line using coordinates. Imagine that you are on a coordinate plane. You could define the direction you go by using 2 points with coordinates. Or you could describe a single point with a slope of the line. Both ways allow you to describe the exact direction you are on. Before we go into this, let's have a quick revision on some basic concepts. In a rectangular coordinate plane, there is a horizontal x-axis and a vertical y-axis, and they intersect at point O, the origin. The coordinates of a point is defined as brackets a, b, while a is called the x-coordinate and b is called the y-coordinate. Now let's look at the point P at the position brackets a, b. And if there is another point Q lying on the horizontal or vertical line of point P, the distance between P and Q would simply be the difference between their x coordinates or y coordinates respectively. In this plot, Q 5, 2 is on the horizontal line of P 1, 2. The distance between P and Q is difference between the x coordinates 5 minus 1 equals to 4. If Q 1, 4 is on the vertical line of P 1, 2, the distance between P and Q is the difference between the y coordinates 4 minus 2 equals to 2. However, what if the coordinates of the 2 points are not directly above, below, or on the sides of the second point? Then we need to use Pythagoras Theorem, a squared plus b squared equals c squared, to calculate the distance between the two coordinates. Let's see an example. When we go between the points P, -3, -2, and Q, 2, 2, we make the distance between P and Q the hypotenuse of a right-angled triangle. We measure the two legs of the triangle, that is, leg 1, the difference between the x-coordinates 2 minus -3 equals to 5, and leg 2, the difference between the y-coordinates 2 minus -2, which equals to 4. Given a squared plus b squared equals to c squared, as the Pythagoras Theorem stated, the distance between P and Q is equal to the square root of the sum of leg 1 squared and leg 2 squared, which is the square root of sum of 5 squared and 4 squared, and it is square root of 41. So therefore, the distance between any 2 points on a rectangular coordinate plane is given by the square root of the sum of the differences between their x-coordinate squared and the differences between their y-coordinate squared. This is called the distance formula. Another concept that is important in this section is the tangent ratio of an acute angle. In a right-angled triangle ABC, angle C is a right angle, and angle A, theta, is a acute angle. Tangent theta equals BC over AC. In this way, the theta could be determined as long as AC and BC are known. for any straight line on a coordinate plane. The inclination is expressed by the angle theta measured from the x-axis anti-clockwise to the line. Another way to describe the steepness of a line on a coordinate plane is the slope. Slope of a straight line could be determined using any 2 points on the line. For example, the slope of a straight line AB equals the vertical distance between A and B over the horizontal distance between A and B. It is given by m equals the distance between their y coordinates over the distance between the x coordinates. This is known as the slope formula. Slope of a straight line on a rectangular plane can be positive or negative. In this example, line 1 shown in the rectangular coordinate plane has a positive slope, as line 1 slopes upwards from left to right. When the slope on the line is positive, the greater the slope, the steeper the line is. Take this line as example. A at -2, -1, and B at 4, 4 are 2 points lying on the line. The slope of the line AB is the vertical distance between A and B over the horizontal distance between A and B, that is 5/6. If we move point B 1 unit upwards, we get point B prime at 4, 5. The slope of AB prime is 6/6 equals to 1. In this case, AB prime has a greater slope and hereby is steeper than AB. Line 2 has a negative slope as it slopes downwards from left to right. In this case, the smaller the slope of the line, the steeper the gradient is. Slope of the line on which point C at -3, 4 and D at 1, -1 are lying is equal to the vertical distance between C and D over the horizontal distance between C and D. That is 5/-4. If we move point C 1 unit upwards and get point C prime at -3, 5, the slope of C prime D is 5 minus -1 over -3 minus 1, which equals to 6/-4. In this case, C prime D has a smaller slope and therefore is steeper than CD. If you have not noticed by now, any 2 points on the same line will produce the same slope. Thank you, and we'll continue on the same topic on the next video.